Hi, thank you for watching my video. I am uploading my videos to share with you what impressed me on astrophotography activities. In this video, I will show you my first trial for an FDM 3D printed case, where you can see the making process in the time-lapse videos. I previously uploaded my Raspberry Pi 5 case trial. It was made from an aluminum plate. I like it because it radiates the excess heat from the RPi. But it was not handy when I used the HDMI extension cable for the HQ camera. The connector board was not stable at all. So, I tried building my own case using a 3D printer this time. I needed to get one for another reason. But it is the fact that I wished to have it quite often for a long time. But it is very tricky to get a good outcome, especially in the low room temperature. The layering failed a few times. This is the sample of another case design. As you can see, the lower layer detached and deformed. One of the reasons is that the material is ABS. It requires a higher temperature than PLA does. The resin heated up to 230 degrees Celsius is rapidly cooled down to a single-digit degrees C environment. So, in the end, I used PLA instead. The temperature for PLA is 170 degrees Celsius, meaning less stress applied to the materials from the rapid cooling is expected. I designed the case using the FreeCAD software. It is not easy to operate, but I like the philosophy implemented in the design processes. Parametric design rule is one of them. I can adjust the detailed features like hole diameters and slit widths later on. In order to get the time-lapse movie of the case being built on the 3D printer, I tried my Raspberry Pi Astrophotography software. I thought it might get interesting results in long exposure. I intended to get an image of the case only, because the printer head is moving so fast that it disappears in the image. Well, the result is total failure. The case is also invisible because it is on the moving stage, and moving back and forth so fast it is better to use an ordinary camera for the object on the Earth. I used the interval shutter function of the Fujifilm X-T10 camera. The maximum number of the shutter operation is 999. So I adjust the interval to get the entire printing. I might adjust the lighting and the image perspective next time. From now on, I can make any necessary parts as I need, for better fitting design than before. Like the Batonov mask for my 100mm diameter Newtonian telescope, and the stepping motor mount on the equatorial mount. I still remember that I spent quite a long time cutting the black plastic sheet with a cutter knife to make the mask. But unfortunately, it was not usable because it was not reliable to fit to the telescope. By the way, this is a totally unrelated thing, but here is the reason I got the 3D printer. I got this cute Zundaman figure a few months ago, but I lost the tail in the parking area in Hakasian ski resort. That was the last moment I took it out of the box. I decided to make the missing piece using the 3D printer. I designed it in Blender and converted the model to STL data. After I painted it with acrylic color paints, I got this nicely fitting tail for this cute figure. Okay, that's all for this time. Thanks for watching this video. See you next time.